The question in this video is what affects pressure? So first we have to define what pressure is, and pressure is force exerted per unit area. In other words, it is how spread out a force is. For example, if you were to stand on your toes, you're now going to make the force concentrated on a smaller area, and therefore you have more pressure on your toes than if you have it over your entire feet. So standing on your toes, you exert more pressure. Standing flat-footed, you have less pressure, even though your force stays the same, your force being your weight. Our equation for pressure, we have right here. Pressure is going to be force divided by area, or we could have that force is pressure times area, or area is force divided by pressure. Now, the units for all of these is, in force, we've always used newtons in the metric system. Area is going to be square meters for us because meter is a unit in the metric system that we're going to be using. And pressure, we're going to measure in something called a Pascal. So down here, pascals is a unit in the metric system versus the English system, which you might be familiar with, is the PSI, or the pounds per square inch. PSI stands for pounds per square inch. Now we want to look at what kind of things affect the pressure, more specifically about a fluid, but pressure in general. The one thing here is that the larger the area, the smaller the pressure. And that's kind of what I talked about when you're flat-footed. You have a larger area over both feet, the entire foot, and therefore there's a smaller amount of pressure. If you have a larger force, then you have a greater amount of pressure. So if you're holding a lot of books and you're standing on the floor, then you're going to have more pressure on your feet because you are increasing the force by holding a lot of heavy objects. Another thing is the deeper you go in a fluid, the greater the pressure. So in a submarine, as you go down deep into the ocean, that is going to increase the amount of pressure exerted on you. And we'll look at how that occurs a little bit later on. Air exerts pressure as well. Any kind of a fluid is going to exert pressure. And air exerts a pressure of 101,300 pascals, which is equivalent to 14.7 pounds per square inch. Now, this is at sea level. Again, that's going to change as you go higher or lower into a fluid. Suction, like suction cups, is caused by an imbalance of pressure. Pressure being greater at one spot than it is at another, and that's going to create that suction. And then finally, we got something called Pascal's principle, which says that increasing the pressure at any given point will increase the pressure equally throughout the fluid. And again, we are going to look at all of these a bit more in detail as we continue through with our note-taking process. The first one kind of alludes to the first statement that we said, was that the greater the area, the less the pressure. And so the question here is, why is it safer to lie on a bed of nails with 10,000 square nails than to lie on a bed of nails with only 100 nails? What I'd like you to do is pause the video, and I want you to answer this question, and then when you're ready, unpause the video and see how well you did. Now, in order to answer this question effectively, you're going to have to use the words area and pressure in your answer. Okay, hopefully you've written down an answer. What you should have written down is something similar to this here. The bed of nails with 10,000 nails has a larger area and therefore has less pressure. If you think of it this way, if you were to lay on one nail, that one nail would have to support your entire body weight, which is a lot of pressure. But if you laid on two nails, that means that every nail would only have to support half your weight. And so because there's twice the area, twice the nails, each one only has to support half as much force, half as much as your weight. If we continue to increase, if we have 10,000 nails, that means each nail only have to support 10,000th the amount of your weight. So the more nails you have, the less of your body weight each nail has to support. So more nails is actually better for you in terms of pressure. If you had an infinite amount of nails, it would be no different than laying down on a flat table. There's so many nails that it's just like a solid surface. Let's go through a problem here. It says in this problem that Jessica is wearing some heels which can have an area of 0.0019 square meters. If Jessica has a weight, which is her force, of 544 newtons, what pressure do Jessica's heels place on the floor? So again, what I want you to do is pause the video, and I want you to answer the question, and then once you're ready, unpause the video and see how well you did. All right, welcome back. What you should have is that we're trying to find the pressure. The force is 544 newtons, and the area is 0.0019 square meters. To get the pressure, we are going to divide the force and the area. Once we divide those two numbers, we get a pressure of 286,000 pascals. Now, I rounded that off. You type it in your calculator, you would get 286,316 point, and then blah, blah, blah. This here, I'm just rounding it off to the nearest thousand. One of the things we said was that air exerts pressure on everything around us. And the pressure from the air is enormous. It is 101,300 pascals, which is the same as 14.7 psi. What that means is that for every square inch of your body, that's a square that is 1 inch on each side. So for every square inch of your body, there is 14.7 pounds of air pushing on that spot. That's a lot of square inches on your body. So that's a lot of pounds of air pushing on you. And so the question is, why aren't we crushed by all of this pressure? And the reason we're not crushed by all this pressure is because there's an equal amount of pressure pushing outward. So if we look at our body here, there is pressure pushing in, and it's pushing from all directions from the air. But the things inside our body, the air in our lungs and our bones and our muscles and the fluid like our blood, that is pushing out with an equal amount of pressure, which is preventing us from being crushed. But what were to happen if we were to go to outer space? Well, if we go to outer space where there's no pressure, or there's no air, I should say, there is nothing pushing us in. But there would still be the inside pushing out. So this is a dangerous situation. If you go into an environment where there's no air, nothing pushing you in, but all that inside is pushing you out, well, we would have a tendency to kind of expand or explode, to blow up. Now, you wouldn't, kaboom, blow up like that, but instead things would just start to kind of ooze out of us. And so it'd be very painful in that situation. And that is why we have to wear a spacesuit when we go to outer space, not just for the oxygen, but we also need the pressure from the spacesuit to prevent us from exploding like that. Now, another thing that we talked about here was that a fluid, the Pascal's principle here, which says that a fluid in a closed container has the same pressure everywhere. And if we increase the pressure at one spot, we're going to increase the pressure throughout the entire fluid. An application of this is going to be a hydraulic press. So if we want to lift a car, what we do is we have a fluid within these pistons. These pistons are connected. So here we have a smaller piston here and a larger piston at the car. At the smaller piston, we're able to apply a small force to the small area. Now the pressure is transferred from the smaller piston to the larger piston. So that pressure is transferred to the larger piston. Now, because the larger piston has a larger area, it will also have a larger force, and therefore it can lift the car. So the pressure exerted at the smaller piston is equally distributed to the pressure exerted at the larger piston. But because it has a larger area, it will also have a larger force at the larger piston. But this is the idea of Pascal's principle, that the pressure is transferred from one location to another. It is transferred throughout the entire fluid. So what we're going to do is we're going to go over a problem to help you understand that the force is actually going to be larger at the larger piston. Here we have a car lift with compressed air exerts a force on the piston with an area of 0.0075 square meters. That's the first piston right here. This pressure is transmitted to a second piston with an area of 0.065 square meters. That's the piston over here. It's larger. The car piston 2 has a weight or force of 13,300 newtons. We first want to know what is the air pressure at the second piston at the car. So I want you to pause the video. I want you to answer this. And when you're done, I want you to unpause and see how well you did. Okay, welcome back. What you should have is that at the second piston, we have a force of 13,300 newtons. That's the weight or force of the car. The area at the second piston is 0.065 square meters. In order to solve for the pressure, we are going to divide the force and the area. When we divide those two numbers, we get a pressure of 204,615 pascals. Now for part B, we want to know what is the force at the first piston. Okay, what is the force at the first piston? So what I'd like you to do is pause the video, answer this question. When you're done, unpause it and see how well you did. Welcome back. What you should have is that the pressure, remember, is transmitted from the first piston to the second. So the pressures are the same. That is Pascal's principle. The pressures are the same. However, the area at the first piston is 0.0075 square meters. Now to get the force, we're going to multiply the pressure and the area. When we multiply the 204,615 pascals and the 0.0075 square meters, we get a force of 1,535 newtons. Notice how much smaller that is than the force of the car. So at this piston here, we're exerting a force of 1,535 newtons. And because the second piston is larger, we're able to lift a larger force. So what this hydraulic does, it allows us to lift heavier objects because the fluid is transmitted with equal pressure from the smaller piston to the larger piston.